Hey everybody, welcome to Revit 2018. In this video, we will be discussing an introduction to Revit 2018 software, and we will be discussing it in 3 different sections. Each of these sections will be a separate video, but they will all be a part of the introduction topic. Section number 1, we will be discussing the definition of BIM software. Section number 2, the definition of CAD software and graphic comparison of BIM and CAD. And section number 3, we'll be talking about a definition of terms. So let's get started. We're going to be discussing section number 1 in this video, and that is the definition of BIM software. What is BIM software? BIM, B-I-M, is a term used to represent building information modeling. BIM software is used in architecture, construction, and engineering to generate construction documents, also called CDs. The term BIM software is a generic term. It's an acronym for a specific workflow used to generate project CDs. However, there are many different brand names for BIM software on the market today. Things like ArchiCAD, Vectorworks, Navisworks, and Revit. Building information modeling has changed how a building project is designed and how the construction documents for the project are generated. BIM is a 3D, model-based, intelligent software-based process that is based around one 3-dimensional model. Let's take a look at what that looks like on the screen. I'm going to pop into a 3D mode here. And again, this is an introduction to the software, so we'll be going over some brief terms, we'll be looking at the interface, and really defining what BIM and Revit software are. Here's our 3D model. So when we say that building information modeling is a model-based modeling software, this is what we mean. When you generate your construction documents, you generate them in model format. And when you want to look at construction drawing sheets, such as a floor plan, you view the model in floor plan view. I just want to show you here that I do have 3-dimensional objects in this model, and I can pick them and take a look at them. If I hover over here near my roof, I can click on my roof, and I can see that it is indeed a 3D object. I keep saying that because it's not a 2D representation of a 3D object, which we'll talk about in the next section. One of the most important things about Revit is that it's based around one 3-dimensional model, and that we have one file that contains this model. The model is parametric in nature, and that's pretty important because it means that there are relationships between different building elements in the model. So let's take a look at what that means. Parametric in nature means that if I am looking at a floor plan view of a project, and I'm also looking at an elevation view of a project, and I pop back over here to my floor plan view, and I click on a wall and I move it, you'll notice that that wall moves over in my elevation view as well. That's what we mean by parametric in nature. That when one object moves, it has a relationship with others, and those objects move with it. Revit uses smart elements in its model to create construction documents. And may be used as a rendering engine for photorealistic renderings. So let's take a look at a couple of those things. Smart objects like got these little people here. We have tables and chairs down here if we zoom in. We have millwork here, cabinets. We have furniture over here that we can see. If I pop over to an elevation, I have railings, and I have windows, and I have skylights. All of these things are called components or families. They're all parametric in nature, and that is what I'm talking about when I talk about smart elements. Let's look at a few of the rendering capabilities. You'll notice in the project browser, which I'm scrolling through to look at views, we have a rendering section. By clicking on each of these views, I'm brought into a rendering. Now, the geometry for this rendering, this photorealistic rendering, was created in Revit. Pretty impressive. And again, I want to say one of the most important things is that this software, this modeling software, this BIM software, everything that we need to create a set of construction drawings is in one file. Now, what's great about that is that design consultants can use our model just as well as we can to coordinate their work with an architectural design. This tool gives design and building professionals the insight they need to more effectively and efficiently draw, design, construct, and manage building projects in their infrastructure. And one really big item to touch on is that this software is a departure from the typical 2D software, such as AutoCAD. Now, I just want to summarize a few things for this section that are pretty important. Number one, Revit uses one file to generate all of the construction documents that we need. And that file contains a 3D model. And that 3D model is viewed in different ways to generate things like a floor plan, or an elevation, or a section. So we have all of the views that we need in here to create construction documents. The next thing I want to talk about is that we have a project browser that manages all of our different views of the model. Here it is. So we can view our 3D geometry in any way that we need to, and it's organized here. One final thing I want to talk about is file structure and file extension. The file extension for a Revit file is a .rvt file. And if I come in here and I save this project, I can see that file structure here. I can see that this project I'm in, which is called RAC Basic Sample Project, I have an RVT file right here. I have a secondary type of file structure or file extension that I have when I work with Revit, and that's a backup file. It's also a .rvt extension, but it has a 4-number prefix before it. And then the final extension I'm going to worry about right now is an RTE extension. And an RTE extension is a Revit template file. I'm not seeing it here, but we will talk about that in a later section. This ends the definition of BIM software section.